Hello, good morning or good afternoon, depending on your time zone, and welcome. My name is Dr. Marissa Biondi, and I'm a Senior Research Scientist here at Tobii Pro. I'm so excited to be hosting this Researcher Spotlight Symposium today. The Researcher Spotlight series is a collaboration between Tobii Pro and our customers to highlight groundbreaking research utilizing our eye tracking systems. This webinar series showcases current and ongoing work to hopefully give you inspiration, answer questions, and create networking opportunities. We have many registrants from all around the world, and people are still logging on. So while we get started, if you want to share where you're located, you can do so by typing it in the chat box. I'm calling in from Texas today in the United States. This webinar will be recorded and shared with attendees, but it will also be posted on our Tobii Pro on-demand webinar hub, where you can find other webinars just like this one. Today we have 5 presenters from countries all around the world who have used our wearable Tobii Pro Glasses 2 in their research. These researchers work in areas of construction science, human factors engineering in a healthcare setting, computer science and robotics, and occupation-based cognitive rehabilitation. Today we'll be joined by Dr. Mohammed Abdelwahab and Dr. Graham Scott at the University of the West of Scotland, Dr. Nima Ahmadi from Houston Methodist Hospital, Dr. Akim Lilienthal at Örebro University, and Dr. Helen Lindner, also at Örebro University. As most of you know, adding eye tracking research to your research toolbox can be a pricey endeavor, often requiring the use of grant funds to make a purchase. Our goal with our Funding Support Services program is to partner with you at any stage of your grant proposal, from the initial concept and finding the right funding call to editing the final product. Each partnership starts out with a live consultation over the phone or web, where we talk through your project idea and determine how we can best help you. We will then stay connected until you submit and follow back up after you've heard back about the results. We have customers who even work with us on multiple submissions for many ideas. This is a complimentary service we offer because the bottom line is, in a research partnership with us at Tobii Pro, when you're successful, we're successful. For more information or how to apply, you can find us on the web at tobiipro.com/FSS or email us at fundingsupportservices@tobii.com. We look forward to working with you. So let's get this symposium started. This is our agenda for today. Each presenter has 15 minutes to share about the research. We will have a roundtable Q&A session at the end where we can ask questions of all the presenters. Please feel free to ask questions in the questions box in the GoToWebinar panel throughout the presentations, and we'll address them in a group at the end. Our first presenters today are Dr. Mohammed Abdelwahab and Dr. Graham Scott, who will share about their application of eye tracking for assessing hazard perception on a Scottish construction site. We'll get started in
Okay, good afternoon, everyone. Can you hear me and see me okay? Marissa?
Yeah, we're ready.
Yeah. Can you see my slides? Yeah?
Yes.
Perfect, thank you. Okay, thank you. Good afternoon, everyone. Thank you, Marissa, for the introduction and for inviting us to contribute to your event today. So I'm waiting on Graham to join me. I don't know what's going on, so maybe he's been held up in traffic. So hopefully he will join us soon. If not, I'll just go through the presentation. So today's presentation is innovation in construction health and safety training practice. And we're going to use Tobii as a use case for using eye tracking for health and safety training. So what I'm going to talk about initially is how did the project all started, and with the project idea, and a bit of context in terms of the project stakeholders, and the research questions which we're trying to address over the course of the project, the research design, and some pattern or some sort of trends in the data. So as you can see here, that's the project team. It's quite multidisciplinary team, and as I mentioned initially, the project started with an idea of eye tracking through a discussion with a colleague at the University of Glasgow. And after that discussion, I just thought how we can start using eye tracking within the context of construction. So as any researcher would do, I'll start doing some literature review in terms of looking at different applications of eye tracking in construction. And then I approached one of my industry contacts, which I've been working with for a number of years, which you can see here is Steve, who put me in touch with Michelle, who's at the front there. And basically, Steve, he's the Morrison Construction Director for Scotland. And Michelle, she's the ESD Managing Director. And they were really instrumental in helping us to provide access to the site and also helping us to develop the project through liaising with different stakeholders. Right, so just to give you a bit of context of the project, so ESD is basically a consortium of a joint venture for Scotch Water, which covers a delivery program of nearly £4 billion. And the framework of that work is basically to provide improvement to Scotland's water and wastewater infrastructure. And as a part of that contract, there is a theme in terms of innovation, how we can demonstrate innovation within the context of that joint venture project. So that's where our project came in, and that's when I approached Steve, and then Steve would put me in touch with Michelle. So the important part of it, so initially we had the idea, then we had the stakeholders engagement, and Steve, as I said, worked with him in the past, so we did a project on using virtual reality for health and safety training. So I thought this could be an opportunity for us to provide an extension to the work that we did in terms of using technology for enhancing health and safety training. I think this is really important because we talk a lot about the research and about the data, but not often there's a discussion about the process itself in terms of how the research came about, and it almost seems like it's a black box in many cases. So an important part of that is obviously stakeholders engagement. So once we got the go-ahead from the project, our industry contact, then we started working together as a team, and Paul, who's basically like two officers from me at the university, introduced me to Graham and Gillian, and then we started then working and developing on the project. So once we identify the site location, so the site location is called Duggy Hill Wastewater Treatment Plant. So it's basically refurbishing an existing wastewater treatment plant, and this is located in the southwest of Glasgow, west of Scotland. And the idea was for us to use this project as an exemplar of how we can go about implementing eye tracking technology within the context of a specific project. Because we're really keen on applied research, because a lot of the research is in terms of tends to be, we're not really, I mean, yeah, of course, we got published in academic, theoretical research, but we are more interested in applied research in terms of how we can. And the way to do this, we need to have boots in the grounds, literally. So boots in the grounds in the sense we go on site, we liaise with different stakeholders. So an important part of the project was to engage and manage a different stakeholder within the project. And as I mentioned, the strategic imperative of that project is to demonstrate how within this sort of joint investment framework, how innovation is used as a way to advance practice within the industry. So I think there might be few attendees from industry today with us on this live stream. So if you're an industry practitioner and interested in working on any of the research, in terms especially on eye tracking, this would be good. Hopefully today's presentation will give you some insights into how this could be done. Right, so as I mentioned, we talk about collaboration. So obviously this work is the collaboration of multidisciplinary collaborations, if you like. That's the formula for collaborations. I already touched on applied research, and through collaboration in terms of every person is getting something to the table or making a contribution, and it's multidisciplinary. Graham is from a psychology background, and basically what we had to do is how to work together in a team in a multidisciplinary way. And as you can see here, this is when we tested the scenarios, which I'm going to talk about in the next few slides. Okay, I think it's worth mentioning here that what obviously I mentioned here at the front, Alex, he's working with one of the contractors on site. We talk a lot about industry changing its face, and there's lots of development in terms of digital transformation and so on. So Alex really done an interesting background. He works as he's a game developer, and he developed a series of, if you like, visual health and safety scenarios or animations for construction. And the reason I'm bringing these up because we use this as a part of our experimental setup. So in terms of, using the eye tracker and how we can, using different scenarios, which I'm going to talk about in the research design. So Alex helped us to give us some of the, animations which he developed. Well, in fact, if I go a few slides there, so this slides you can see is most undeveloped by Alex, and you can see there. Okay, he actually has a YouTube channel, so you can check it out. Right, so in terms of, so that was all in terms of just a background, just to set the scene in terms of the project context and location. So in terms of the research questions we're trying to address, we know in construction there is a perennial problem in terms of health and safety. There's often tons of reports and government reviews were published on in terms of how we can have zero fatalities on a construction site. So there are many. So if you look at the latest data published by the HSE, which is the Health and Safety Executive, so in the UK, that's the go-to, if you like, resource when it comes to health and safety statistics and health and safety guidance and information. So it's a very comprehensive source on health and safety in construction. I often point my students to that and as the go-to website. Anyway, so on that website, you've got lots of data on the number of construction fatalities and the causes of construction fatalities and so on. So things like being struck by a vehicle, being struck by a moving vehicle, falling from heights. So these tends to be some of the top causes of fatalities on a construction site. If we try to dig a bit deep in terms of understanding why these accidents happen on the construction site, well, we all know the construction especially have a macho culture. So if someone working in industry for a number of years, they probably have got too familiar with the site, and that's when they become more prone to doing accidents. So the failure to recognize hazards on a construction site is one of the issues or problems when it comes to addressing health and safety risks. So we were set out to address these two research questions, if you like. So why are some hazards go unnoticed, and how workers perceive a construction site? And we thought using eye tracking would be a powerful way of doing this, because eye tracking simply capture objective data. So it's recording eye movement and could provide dynamic trace of where a person's attention is. So it's really a very good way of gauging the visual attention of the, in our case, the trainees who were participants in our experiment. So we had areas of interest. So what we developed is obviously informed by our literature review. So we really wanted to do like simple pilot project because obviously we had limited resources for that project, and it's really small scale pilot project. And the idea was for that project was to show and tell the industry what could be done using the technology, because we know industries are very busy and they don't necessarily have the time to look into these technologies. So we thought this pilot could be a good way to show and tell how the industry in terms of eye tracking in practice, if you like. So eye tracking gives us this objective feedback on training performance and hopefully help in advancing training standard by gauging visual attention. And the way we tried to set up our experiment weeks, we tried to divide our participants into two groups, experienced and non-experienced. And obviously we collected some qualitative data in terms of looking at the participants' background, their age, years of industry experience, qualification, and so on. We'll come back to this later on. So in terms of the role and my contribution to the project was, as I mentioned at the beginning, the originator of the project idea, and obviously scoping out the project, what we can focus on. And as I mentioned already, that we don't want to pick something complicated, so we decided to do something which is really simple. So we did use the desktop Tobii, so we didn't use a mobile eye tracker, we used the desktop eye tracker. And the desktop eye tracker we used we tried, obviously informed by literature reviews. We've seen similar studies in the past using using different construction scenes and using the eye tracker and trying to ask the participant to see what hazards they can see in the picture. And this was the main idea in terms of trying to understand their hazard perception of different hazards on a construction site. And that's when I was supposed to pass on to Graham. I don't think Graham is coming. Maybe he's been held up in traffic, so I'll just press on with that. So in terms of eye tracking, data provides construction professionals with a new perspective, if you like. So it unlocks the potential of giving you, we often talk about data. So this gives you another set of data within your toolbox, if you like, to help manage health and safety effectively and ensure that trainees are well trained to the required standard and they perceive a construction site. I mean, I mentioned the research problem. We're trying to address that. There are a lot of fatalities on construction site anyway, and we try to minimize this. And also, training is a real challenge in construction, especially when it comes to site induction. So often practitioners in site inductions, usually the site induction is generic and is not necessarily related to the construction site. So how we can try and make the site induction more bespoke, if you like. So moving on to the experimental setup. So as I said, this is setup which we had, and we had a desktop eye tracker, and that's what we use to capture our data and examine the trend in the data. So we structured our experiment into two parts. So part one is getting familiar with the site. So we really showed the participants, as I mentioned, we tried to split them into two groups, experienced and non-experienced by years of experience or how long they joined the industry. So we had apprentices who just started in the industry recently, and we had more experienced workers who've been in the industry for 10, 15 years. And that was really interesting just to see the change in terms of perception. So getting familiar with the site, so we showed these different scenes on the desktop, and they were just trying to ask them to look and identify these areas on the site. And then we used the heat map to try and distinguish between the experienced and inexperienced workers, which is a good way of looking at where the gaze of the participant in the experience is concentrated in the scene that they're being shown. So these are the different areas on site. So we're trying to ask them a question, and then we can say, okay, identify this area on site. And this is really important for understanding site awareness. Another important aspect is the site safety board, which is communicate the key site information. And that was a really interesting one because we're trying to look at where they're actually looking, and we'll be able to see the experienced versus inexperienced workers, where the level of attention is. So that was really good, and I think we thought that this might be a potential area for optimizing the design of the site safety board. And this is another safety board as well. So is this like the most effective way of communicating site information, or how we ensure that the workers focus their attention on site critical information? Then we moved on to the hazard perception in terms of looking at, so we had the different scenes, and we asked the trainee to look at the picture and or the participant experience in the experiment, look at the picture and identify where the hazard is. And obviously we used again the heat maps. So we tried prior to asking them to look at the picture, we tried to map or outline the areas of interest. So this is the AOI in terms of area of interest, which we think these were the hazards. So we need to make sure that their gaze, plot, if you like, would match into these areas of interest. So there you go. So these are again the heat maps between the inexperienced and experienced workers. And as you can see, one of the issues is in terms of having an overhanging load on a construction site. So this is potential. So we need to make sure, hazards. So we need to make sure that anyone, in that area will keep away from just, from this part of the site, because it's a potential hazard. Something might fall on their head, or also moving vehicles, because that's one of the risks which, when we talked about it to industry practitioners on site, that one of the issues they talk about this site, there's a lot of moving vehicles. I know I've got 1 minute, so I'll probably need to wrap up. One of the other things is, so we talked about moving vehicles. So this is one of the animations which we used from Alex, which I mentioned earlier. And again, inexperienced workers. So just to finish off, I mean, eye tracking really provides an objective data capturing method for gauging the visual attention or the cognition level through eye tracking movements. So that's really important for us to ensure that training is effective, and also that we eventually reduce fatalities on the construction site. We found that experienced workers have better situational awareness of the site environment, so they tend to look, evident by the heat map, they tend to look more on the site, have more analytical view of the site. Already mentioned that eye track can provide quality assurance for training. We know there's a lot of work that could be actually done. We already just done, so we're only scratching the surface. We just used static scenes, so we can use more realistic scenes for assessing hazard perception using eye tracking. Also, we talked about optimization of the site safety board. And I think I'll finish now on this because it's only 15 minutes exactly. I hope I'm on time, Marissa. So that's it for me. Yeah, if you have any questions, I'll be happy to answer them. And please feel free to connect on LinkedIn and send a question to myself or to Graham.
Awesome. Thank you so much, Mohammed. Really appreciate it. So yes, everyone, as I mentioned before, we're going to have a roundtable discussion at the end. So you can please ask your questions in the questions box in the GoToWebinar panel on the side, and we'll get to them at the end. So now our next presenter is Dr. Nima Ahmadi. Nima will be here to discuss an application of eye tracking technology in intensive care units and naturalistic evaluation of nurses' mental workloads. So keep in those questions in the questions box. And Nima, you can take over at this point. Do you have your presentation on your screen? We were having some technical difficulties, so it'd be better if you can present yourself. If not, I can move. I have it for you, but I can. Oh, your audio isn't working. Sorry, Nima, we can't hear you. No, I can't hear you. It's not working for some reason. Did you try selecting in something else in the audio settings?
Excuse me.
I can hear you now.
Okay, sounds good. Sounds good. So, good morning, everyone. I am Nima Ahmadi, postdoctoral fellow at the Center for Outcomes Research, and I work on different studies. Today, I'm going to talk about a study that we conducted on CVICU nurses in order to evaluate the mental workload. Marissa, do you have my slides? If you can share them, it would be awesome.
Can you see the screen?
Yes.
Okay. I'll have to move the slides along for you.
Okay, sounds good. If you go to the title of this research is Naturalistic Evaluation of the Workload and Stress Among Intensive Care Unit Nurses. Go to the next slide, please. I would like to mention that this was a group work, and I had a pleasure to work with Dr. Sasan Gohat, Dr. Yu, Ms. Yang, and Dr. Danish in this project. The objective of this project, this study, if you go to the next slide, please. The objective of this study actually was a subset of ICU burnout study, which was conducted in order to investigate nursing activities in 12 hours working shifts in order to identify ICU stressors and explore the correlation between stress and physiological responses. But it was of particular interest to explore the mental workload of ICU nurses and examine the effect of ICU events or code blue on stress of nurses. Next slide, please. Let me see. Yep. Right now, we published 2 papers. In the first paper, we share the experience of getting IRB approval from IRB approval for using eye tracking technology in an intensive care unit nurses. And we know that in intensive care unit nurse, HIPAA has a strict regulation in order to protect patient safety. So it's a little bit challenging. In the second paper, we shared the outcomes of studying correlations between the stress and physiological responses, heart rate, electrodermal activity, and skin temperature. Okay, let's look at this, the current study. In a naturalistic data collection, we captured data from 21 CVICU nurses. It stands for cardiovascular intensive care unit nurses using Tobii Pro Glasses 2 and Empathic IE4. The objectives were to compare their mental workload during the day shifts versus the night shifts, and also we were interested to see how visual stage of ICU nurses changes as a result of stress. And okay, this presentation has 3 sections. First of all, I start with the introduction. I'm going to talk about intensive care units and the methods for the workload assessment. Then I'll talk about the applied methods in terms of data collection, the tools that we use, and apply the statistical models. And I'm going to wrap up this presentation by looking at the result and the discussion. Okay, workload is one of the key job stresses of intensive care unit nurses. This factor is associated with patient safety and quality of care, and which increased length of stay and mortality rates of patients as well as clinicians' medical errors. Furthermore, workload has been linked to burnout, which adversely affect the healthcare system by increasing absenteeism and turnover rates of ICU nurses, and organizational cost, which is estimated to be between $1.4 to $2.1 billion per year. ICU units were developed in order to provide acute caring environment for patients in acute conditions, and nurses use different devices such as bedside vital monitor, respirators, in order to take care of patients in those conditions. These units are characterized by continuous background noise, alarms, and flashing lights, and multitasking is a common practice in ICU units. Prior studies have shown that nurses perform a high number of tasks per hour, 23, and they receive different sources of information from the verbal to written, auditory, and visual information by interacting by different devices, other physician, nurses during the working hour. This means that if you go to, achieving a high level of situational awareness and making informed decision making would be challenging for ICU nurses because they are susceptible to cognitive overloading, which is linked with the failure in information processing and errors such as inattentional blindness. Enzyme model of situational awareness, which explain the process of decision making in the different domains, will explain this one. But due to not having enough time, I'm not going to talk about that one. But if you look at the level 2, which is interpreting the patient situation, related to the data, this could be affected by a high level of workload that nurses receive by getting the information from the surrounding environment. Actually, this is the main reason that we conduct workload assessment in intensive care unit nurse in ICUs, to make sure that the staffing is at a good level to prevent cognitive overloading among nurses and avoid medical errors in the units. In the ICUs, workload is measured using 2 different approaches. One of them is patient-based measures, which in this case, workload is estimated based on patient's characteristics such as patient acuity, namely using a scoring system such as TISS 786 and NACE. The drawback of using this system is that these systems are good for evaluating of workload for a day or one working shift, which could be 8 hours or 12 hours working shift. Another approach is to use NERS-based measures, which are classified and grouped into subjective and objective measures. NASA TLX, for example, is one of the subjective measures that administered in the units in order to evaluate the workload of nurses. The drawback of administering the questionnaires is that they suffer from bias in responses. Also, they're not good for the real-time monitoring of the mental workload. Another reason that we're not into using subjective measures in order to evaluate workload is that interrupting the nursing activity during the shift is not recommended, because the priority is to take care of the patients who are in acute conditions. An alternative approach that could be used in order to address these issues is to use wearable technologies to assess, to collect physiological responses, and then evaluate workload based on the documented correlations between the mental workload and physiological responses such as heart rate, electrodermal activity, and eye movements data. However, eye tracking technology has been used in different domains such as driving and aviation, which I personally use them in order to develop a training intervention and perform behavior assessment. In the domain of healthcare, its application is limited to the laboratory setting experiments, which is where it was used to perform visual attention assessment, to explore decision-making of clinicians, to assess skills of clinicians, or develop training interventions for nurses or physicians. Only in one naturalistic study in the domain of healthcare, eye tracking technology was used in order to record videos and perform post-video analysis. If you go to the next slide, please. So in this research, as I explained, we were interested to evaluate mental workload of nurses between the day shift and night shift. And when we look at the prior research, we figured out that only 2 different approaches were used in order to compare the mental workload of ICU nurses between the shifts. Either researchers employed a scoring system to evaluate the workload, or they used wearable technologies to log accelerometer data and then estimate the workload based on physical activities or energy expenditure. To the best of our knowledge, no naturalistic studies has been conducted in ICU units in order to assess nurses' mental workload using the eye tracking technology, or in other words, eye movement metrics. The main reason also, or the main motivation that we conducted this study, is that the context or the nature of the nursing activities have changed over the time from the physical to the mental. So this type of assessment, and we think that is appropriate to evaluate to fairly evaluate the workload of the ICU nurses. In this study, we collected data from the CV ICU nurses during 12 hours working shift, which was started at 7 a.m. to 7 p.m. and 7 p.m. to 7 a.m. We collected data from day shift and night shift. If you go to the next slide, please. We used 2 devices to collect the data. Tobii Pro Glasses 2, which is a head-mounted eye tracking device. It's a lightweighted device, and Empathic IE4. This device record data at different sample lengths due to having different sensors. If you click on the screen, please. And also we use copious software in order to generate a stress index, which this software actually computes the stress index according to Babinski stress index. The SI between 80 to 150 is considered normal. We define a stress zone for low, normal, and high based on this range of the stress index. Then we use a Python script in order to synchronize the data, eye movement data and the stress index data, and then we had enough data. We made the data ready for further analysis. Also, in order to evaluate the mental workload and looking at the visual search of the ICU nurses, we compute 4 categories of eye movement metrics. Fixation metrics, staccato metrics include duration and number of fixation staccats. Also, we look at the pupil diameter and we use entropy and nearest neighbor index in order to quantify randomness of visual search. Let's look at demographic information. As you can see here, for two types of analysis that we conducted, the majority of the participants were female, and most of the data were collected during from the day shift nurses, and the age of the participants was about 34 to 35 years old, with the ICU experience of approximately 7.5 to 8.7 years of the experience. We use two different statistical models in order to evaluate mental workload of the ICU nurses, as well as to explore the impact of the stress on the eye movement of nurses. We used a mixed effect model for each eye movement metrics, where the response variable was the eye movements, the fixed effect was the working shifts, also the random effects here in this case was the participants. To look at the effect of a stress on the eye movement or the visual search of the nurses, we use ordinal regression model with a random effect. Where the fixed variable here was the eye movement metrics with the interaction with the shifts. Okay, let's discuss the mental workload of the ICU nurses. Two metrics, fixation duration and entropy, didn't satisfy the normality assumption of the model, so we had to remove them from the data set. Also, we transferred the pupil diameter to the log form in order to satisfy the assumption. Okay, based on prior studies, we suspected that maybe day shift is more demanding than the night shift. The reason is that the prior studies based on accelerometer data showed that the ICU nurses during the day shift, they have more physical activities. Also, they have more energy expenditure. Besides, the NACE score of day and evening shifts were higher than the night shift. But when we look at the NNI, number of fixation, number of staccat, duration of staccat, and pupil diameter, we didn't find any significant difference between the day and night shift mental workload of the nurses. If you go to the next slide, this is associated with the method that the workload was measured by the prior studies. For example, NACE estimate nursing workload based on 23 nursing activities. These activities covers a variety of tasks such as positioning patients, medication administration, family communication, and doing a specific intervention such as patient intubation. These are a combination of physical and cognitive tasks. If you go to the next slide, and any time that we want to consider the estimate the demand of each task, we should pay attention to its component. If they have the skill or rule-based, if they are the skill or rule-based task, we know that they are governed by a structured pattern of thoughts and deterministic rules, so they don't need a high level of workload, mental workload. But on the other side, if the tasks are considered as has the knowledge-based component, then it requires reasoning and novel solutions to accomplish that task, which means that the task compared to the skill and rule base going to be more demanding. Same idea, same concept is applied when we evaluate the result of those studies that reported that nurses had higher physical activities or energy expenditure during the day shift. They only focus on one aspect of the workload, which is the physical. If you go to the next slide, please. Okay, and the second question, or the second the areas that we were interested was to explore the impact of a stress on eye movements of ICU nurses according to attentional contour theory. We expected that stress makes nurses more susceptible to distraction. In other words, the ability to control their movements, narrow their attention on a specific task reduced as a result of a stress. So we anticipated that stress increased the number of fixation an increase in the entropy as a result. Subsequently, we expected that duration of the fixation decrease, and we guessed that the duration of saccade as a result of having more movement during in the surrounding environment decrease as well. Here's the result. When we look at the number of fixation, entropy, and as well as the duration of saccade, we see that the change was significant in desired or in anticipated direction. The surprise was the pupil diameter. We know that the pupil diameter expand during the under the stress, but here we notice a significant different change. The pupil diameter actually was smaller during the under the stress. This could be associated with those nurses who work in the night shift, and they go to the patient's dark room in order to do a few tasks. So right now we're reviewing the videos in order to understand exactly what happened during the shift. If you go to the next slide. As a conclusion, I would say that there are different ways that we can measure workload. The result could be affected by those measures, but we think that eye movement methods have the good potential to be used to assess the mental workload of ICU nurses. We heard the similar complaint of the night shift nurses, that there is an assumption that night shifts are lighter than the day shifts. This study support that claim that is not the case. Both shifts are fairly the level of the mental workload of both shifts are similar, and we noticed that the stress increased the number of fixation and entropy and decreased the duration of saccade and pupil diameter. And if you go to the next slide, in the future, we're gonna take a few more steps. We're gonna tag the videos, and then we want to figure out which nursing task according to NACE elicit a higher level of mental workload. So we want to be working on developing a real-time monitoring system to detect nursing activities and elevated workload and stress. If you go to the next slide, please. Thank you so much for listening to this presentation. Dr. Sasan Gohar is the PI of the project. He would be happy he's gonna be happy to be contact from you, or if you have any question, please feel free to contact me. I can answer those questions as well.
Thank you so much, Nima. Really appreciate that. Was so interesting.
Of course.
We're looking forward to all of the questions. I've already seen that a couple have popped up in the question box, and we'll hold those for now, and we will move on to Dr. Lillian Tull.
Thank you so much.
Okay, I have to select the correct screen here. Screen of monitor 2, clean. Now screen of monitor 1, clean. So do you see the first slide of my presentation now?
Yes.
And you hear me well?
Absolutely.
Good.
Yeah, I can see you now.
Thank you very much. Okay, so a bit different from the previous presentations, I want to give more of an overview of the different directions that we are following, and only dive into one study a bit more in more detail. So I want to talk about intelligent eye tracking based support systems as we see them being useful for mobile robotics, where we initially developed an interest, and also now we are working beyond that, so where there are no robots involved. All right, can I change the slide? Okay, so I want to start with a very quick overview, a few sentences of who we are, what we are working with, and especially I want to say something about autonomous mobile transport robots, which when they work together in interaction with people, created the interest for us in human-robot interaction and then in eye tracking. From that, I want to start with basically the history of our interest, which started in eye tracking studies, wearable eye tracking studies, when we were interested in the details of the interaction between a human and a robot. From that, we moved on to implicit intention communication. I will explain what that is in the fourth section. And then I talk a little bit about applications, which are currently very hot here beyond robotics. Okay, so I'm head of a research lab, which is called the MRO lab, Mobile Robotics and Olfaction. And here, just to show you a few of the robots that we work with, we are between 25 and 30 people, and we work with robots that are supposed to do different tasks. We do basic and applied research, and we try to bring our innovations very quickly also to the market. And so we are associated with a spin-off company as well. If you try to extract what is the common feature of the interest of the people in the lab, then you could say the fundamental interest is in perception for intelligent systems. So we actually have sensors that measure phenomena in the real world, and then our task is usually to interpret those signals using, for example, artificial intelligence, representing them somehow in a computer, often in a robot, and then select appropriate actions of this robot or interaction with people. And that's where our interest in eye tracking came from. So we are, for example, interested in robots that can smell and that are applied in different monitoring tasks and in agriculture, but I won't talk about this today. Primarily, we are interested in intelligence perception for mobile robots, and with perception here, I don't mean gas sensing, I mean 3D sensing and vision, computer vision, for example. So a frequent use case for us is autonomous mobile transport robots, robots such as this forklift or the two smaller ones here that need to bring stuff from one place to another. And since this happens more and more often in environments that are shared with humans, it's very natural that we developed an interest in human-robot interaction. And because we wanted to study this in more detail, we started to look into eye tracking-based support. So that tells the whole story. Now let's look at these autonomous mobile transport robots. And I want to start with 1 minute of our advertisement video of one of our most recent projects, so one that we concluded just recently. So I hope you can hear the sound. Otherwise, please let me know, then I will talk over the slide.
Iliad is a Horizon 2020 European Union funded research and innovation project. In this project, we have 9 partners, 5 from industry, 4 from academia, and we come from 4 different countries and work together to develop solutions in which mobile robots, mobile autonomous forklifts, work together alongside with humans, for example, in warehouses to handle the logistics, where they bring goods from one place to another, so that, for example, they put them on pallets and bring them to the place where they are needed to. They self-deploy, which means you bring them into the environment, and then they learn how to optimize their behavior. They learn how people actually behave there. They interact safely. There's a lot of consideration of safety, and they recognize the goods and handle them with a dual arm system.
So you've seen that the person there was falling on the floor, and that was basically because we developed a camera that detects people very reliably. But I often get the question, why is it that you, or is it maybe that you could detect that this person has a problem before? And generally, how do you interact with these people? And if you look at this slide here, which shows the robots, some of them are much larger than actually just a forklift. And so it is really that as a person, you want to know what these robots are going to do. And the interaction with them is actually very, very important so that we study it. So here is the general outline of the talk again. We are interested in human-robot interaction. And because of that, I will now in the first part tell you something about our approaches for eye tracking in robotics, and in the second part saying something about eye tracking beyond robotics. So as I said before, the initial interest came from the interest in human-robot interaction. What happens in detail? And for that, we use wearable eye tracking technology. One idea of a robot that tries to communicate its navigation intent to people is that it projects it onto the floor. So that is supposed to enable trustful, efficient, and safe interaction. So safety, the robot can hopefully guarantee also in other ways, but the efficient interaction with humans and the intuitive interaction with humans, that is something that we are after. And here we use a mode that we call spatial augmented reality. So you see that on the next slide, the robot projects patterns, different patterns, and we wondered which ones of them work best in interaction with people. And therefore we ran studies where participants meet a robot on a narrow corridor, wear eye tracking glasses. As you can see here, at that time we couldn't afford the Tobii glasses when we started with this direction. And then here you see on the next slide, I hope you see one of these encounters. So we actually were interested in how often does the robot, the human look at the projection, how often does it look at the robot itself. That's actually a bit jumpy. I hope you got the gist here. A second way of interaction between people and robots that we're looking at is if we actually fit the robot here with a fake driver. So this robot is of course not driving the forklift, but it's there as a measure or as a way to intuitively interact with a person. And we see that in the videos on the next slide. I hope it changes. So a person approaches the robot, and on the left you see an experiment where the person actually wears eye tracking glasses, and on the right, that's in an early stage, communicates with the robot on the forklift robot. And then the humanoid robot, so we call this anthropomorphic intention communication, shows with the hand where to put the parcel. The robot tracks the person. The robot tracks the head of the person so that it can naturally communicate with it. And of course, in these experiments, we are interested in where does the participant here look at what times do they look at what parts of the robot and the fake driver. Then finally, a third direction here where we are interested in details of human-robot collaboration is what if there is not a single person, but rather several people and a robot in the room. So here we have experiments with eye tracking where we have people assigned certain roles. So we have, for example, a worker, an inspector, or visitors, and they, according to these different roles, get tasks, and then they walk around in the environment and interact with the robot naturally. And then we record all this data with very high precision localization. That's why they all are wearing these helmets. And for some of them, we also have eye tracking data. So this is not yet fully evaluated, but the data set is available. Okay, now back to the initial use case. Implicit intention communication, that's what I want to talk here. And what do we mean by that? Well, if we are thinking about these experiments, so that is currently something that a researcher evaluates, but what if we think about an industrial environment where the owner of the company introduces rules such as people should wear safety vests, but they could also say that for safety reasons, people should wear eye tracking glasses. And if they wear eye tracking glasses, then we can establish a connection, a wireless connection, and transfer the gaze points directly to the robot and establish a connection between the two. And here I just show very briefly an experiment that we made. So a human meets a robot on a narrow corridor, and we check whether how often it looks to the left of the robot, how often it looks to an area of interest to the right, and does this agree with which side the human then in the end chooses. We ran this with a number of different different paths that we gave human and robot, but all the time they had to actually meet in a narrow passage. And indeed, we found that, so without going into details here, we found that the people indicated in most of the cases the direction in which they, like at the side to which they would pass. And this is a very, very simple experiment. So we would just evaluate, you know, all the times when the robot, when the human can see the robot, and have not yet made an attempt to find features which with even higher certainty would indicate that the robot should rather give way on one side or on the other. So that is encouraging. And here I have a small example of this connection between the human and the robot through eye tracking, where the robot is actually trying to signal that it wants to go in this direction. And if it doesn't have the attention of the human, then it starts to blink. So we see that here. If the human looks at the robot, then it says, okay, it has seen me. And for the purpose of this demonstration, we run this several times. But of course, here is many more possibilities are, you know, like, for example, trying to detect whether this is an expert that I'm interacting with, trying to detect the state of fatigue, and so on. So this is all robotics, and you might have noticed that this is a pretty hard use case with changing illumination conditions and so on. So we naturally also are interested in eye tracking based support systems beyond robotics. And here, especially the connection between eye tracking and artificial intelligence is promising. So now for the last part, I will say something about eye tracking beyond robotics. And here I want to primarily mention something that seems to be a very powerful way of combining computer vision, eye tracking, and artificial intelligence in recently we are currently in the process of making this a startup company where we see this using eye tracking here as a support for driving assessment. So for the teacher, for the student, and we see here a small example. So you drive, you have the eye tracking glasses on, and afterwards the software can actually produce these clips where it shows, for example, that the stop sign may have been seen too late. So we have some first pilot project here, and I'm pretty sure that we will soon have a larger project as well, because that actually raised in Sweden quite a lot of strong debate. We were in the main evening news with that, because there is a lot of discussion about how to properly evaluate, especially older drivers, which sometimes seem to be treated unfair. We got a lot of letters that said, this is my hope that I can finally prove that I can still drive. And so we are currently pursuing this in projects, in research projects, but also moving this to the innovation side. Okay, this is my final slide. I just want to say the combination of wearable eye tracking and AI is very powerful. We have seen that in basically what we call QTPI, quantitative tool for practical driving improvement and examination. This is the general idea, and what I showed was the DASH project, which is the first project out of in this line of in a line of projects, I think, and there will be more. And then we also do eye tracking for education. I cannot say much about it at the moment for time reasons, but also because there are patents pending. And in this way, I also met Helen Lindner at Örebro University. We discussed this, and then Helen started this promising research on using eye tracking to understand and support the process of learning to use prosthetic limbs. And with this last slide, I'd like to thank you very much and say that, of course, what I presented was a collaboration with many PhD students and many great colleagues. And then I would hand over to Helen. Thank you.
Thank you so much, Akeem. That was fantastic. So exciting to hear about your work and a perfect setup for Dr. Lindner, who is next. As Akeem mentioned, our final presentation is Dr. Helen Lindner, who will share about her work using eye gaze to trace cognitive processes during operation of a multifunctional prosthetic hand. Thank you so much for being here today. I'm excited to hear about your research.
Thank you very much. Should I take control or you show it, or what have we decided?
I will make you the presenter. Oh, here we go. You should be
Okay,
ready
show
to
my
go
screen.
on your end to share.
It's a bit slow here now. Wait a second. Can you see my screen?
Yes, looks perfect.
Perfect. Okay. Let me see. I want to minimize this viewer for me because it's kind of in the way. Okay. Hello, everyone. So this presentation is about using eye gaze to trace cognitive processes during the operation of a multifunction prosthetic hand. And this presentation is part of a collaborative project between Örebro University and University of New Brunswick. My question to you is, do you see my viewer on the screen? Because you're sharing, you see my screen.
I see your screen, yes, and your video.
Yes, I don't know how to make it like, is it in the way? Wait a second, how to?
No, nope, not in the way.
Okay,
Looks good on
no
our
problem.
end, thank you.
Okay, perfect. No to the next. Okay, so I'm going to go through a little bit, start with talking about what is prosthetic training, and then I'll go on to talk about why do we use eye tracking in this research. And then I will share my experiences, how we use the eye tracking glasses to track or to trace cognitive load during the learning of a multifunctional hand, and also our experience, how we have been using eye tracking to monitor learning. And at the end, we can have some coffee together. Okay, in normal prosthetic training, when the patient comes to the clinic, they are fitted with a new prosthetic hand, like a multifunction hand, then they stay with us for a few hours. Then we will train them. So the first part of the training is usually called control training. So what we do in the control training is we help the user to discover how to operate, how to come into different groups. So in this control training, we will focus on grasping, holding without dropping the objects, and releasing, which is put the objects on the table, for example. And we're training this grasping, holding, releasing using different objects of different sizes, different shapes, different texture, and different weights. And in this video, you will see my research colleague, Wendy. She is actually training the patient to come into pinch grip, but you can see in the video that he has problem doing it. So now you can see he can use his pinch grip and to stack the wooden blocks on top of each other. Okay, I'll go to the next slide. So why do we use eye tracking? simply just because we want to measure, one of the reasons is because we want to measure attention. We want to see where the person is looking. Where does he put his attention? Because we also notice that some patients learn faster. Some patients learn takes longer time. And one of the very important cognitive function in our brain is attention. So we want to quantify this. We want to see, do all the people look at the right place, or do all the prosthesis users have similar pattern of problems? And when they come to us to learn how to use the hand, we also have to make a decision how many grips we're going to teach them before they go home. 3 or 4 or everything in the hand, because bear in mind that one prosthetic hand can have like up to even 26 different grips then. So we have to make a decision when they come to us, how many grips we're going to teach them with the first teaching. Sorry. So one of the things that we have been using eye tracking is we want to trace the cognitive load. Like I mentioned before, we do not have objective data to help us to determine if a person is experiencing like excessive cognitive load, or they are ready to progress to learn something more advanced. So for example, you saw the video just now. So you might be guessing which part of the learning is most cognitively demanding. Was it when the patient tried to initiate the grip, when he tried to come into pinch grip, or when he was grasping the wooden blocks? And of course, from the literature, we all know that if you have a larger pupil diameter during a task performance, then it also indicates signs of excessive cognitive load. So what we did was, of course, we extracted out the pupil diameters when 3 prosthesis users were during the control training, and we noticed one thing is the pupil size were the highest when the prosthesis users are initiating the grips, which means that they're trying to come into the right grip. And so in one user, he has difficulty initiating grips at different times. In another user, is like also has difficulty initiating a grip. But we also notice that in our data, it's like when the person is adjusting the grip to get a better position, it also have a higher pupil diameters. Like in this case, the person was using a knife and fork, and because if the fork is like, he was holding the fork in between his fingers, and it was not in the best position when he was holding it, so he tried to adjust it, and then that was the time also has a higher diameter. And in the clinical practice, we always use some sort of standardized clinical assessment to see if the person, when they come back for evaluation or follow-up, we will definitely measure them to assess them. How is their prosthetic control? Are they advancing, or have they been like not using their hands in their daily routine? And usually we will ask the patients to do some sort of daily activities, or in this case that the patient is going to put together a lampshade. So he take out a light bulb and also a cord, and then close the cupboard. And usually the therapist will stand next to the patient and to assess him with different assessments points, if I would say, items. And in this assessment, which is widely used among the therapists in the upper limb prosthetic field, you can see there are 4 different assessment items that assess if the person needs visual feedback. What it means by very simple is like, we want to see if the person has to use, we look at the prosthesis when he is holding something, or when the patient is grasping something, or when the person is adjusting something. Does he need to look at the hand? And when he's like putting something on the floor, back on the table, for example, if the person needs to look. Why looking is so important in prosthetics is mainly because if you don't have to look at your hand when you are using it, you are showing us that you have already integrated your prosthesis into your daily routine, into your daily life. So what is good about using eye tracking is just simply that it quantifies the visual feedback for us. So we don't have to stand next to the patient and guess anymore. So we can actually see if the person is actually looking. Bear in mind that prosthesis does not provide any sensory feedback to the person. So when what you're looking, you think it's a hand, but is this a hand that does not give you any sensation? So you have no idea how it feels like when you're using the hand. So new prosthesis users always rely on visual feedback or visual cue to know that when they are grasping something or when they are releasing something. Sorry. So I'm going to show you another test that we also can use to monitor learning progress. And in the first video, I want you to pay attention to see if this is the same patient. He has an old hand, which is called standard mile hand, and this is 2 weeks later, and we assess him with the same thing that he's using his new hand. And you can see in this video, he's basically not looking at his hand when he was grasping this triangle. And after 2 weeks of training, I mean, after he has been training for a few times, you can see that he actually was thinking how to come into pinch grip. And you see he went into the wrong grip, which is a lateral grip, and then he's trying to come into the pinch grip. So he made it. Wait, sorry, it is a bit funny about this. So of course, from literature, we all know that gaze, how is it? Oh, something is missing here. Gaze behavior can be used to indicate degree of learning. What does it mean? That it's like for us, in our case, it's a bit like we want to know the gaze duration, which is we want to see how long the person has to look at prosthesis and on the objects. We also want to see if the number of fixations, distribution of number of fixations on the prosthesis and on the hand, and on the prosthesis and on the objects. And so in our data, we have followed, this is the data of one patient. So we follow him for 1 year. And then we noticed that in his standard mile hand, you can see the number of fixations was low because he didn't really have to look at his hand so much. But when he's used the new hand, it was like after 2 weeks, the number of fixations went up a lot. And he did not really pay so much attention to the objects. But then after 1 year, the number of fixation also went down, which is good. But our ideal case is hopefully he actually can, the number of fixations will be the same as the hand that he used before. And this is also in the same thing. He's like using the test in in heavier objects. So in our case, it's like if you have to measure things heavier, if you have to carry things heavy, hold something which is heavier, and it also you will put more attention to it. And which is, in a way, the data actually show us quite reliable result. Hey, wait a second. How can I cannot see my mouse. Something wrong with my mouse. Wait a second. Wait. So, and in this gaze plot, you can see, which is I try to plot it to show a little bit clearly. Of course, when you're using a new hand, you will look at your hand more, but when it's your old hand, that is like you're driving an old car, a car that you're very used to. You don't need to look at the gearbox anymore when you're changing gear. And one of the things that we also extracted out from the Tobii Pro Lab is a measure called average fixation duration, which is when you search in the literature, this would actually indicate the cognitive processing difficulty. And what we noticed that when the person is using the hand, and we'll notice that when he's using his usual hand, the time, the second is the average fixation duration is much shorter. And after 2 weeks, it went up. And then after 1 year, it came down a little bit. As we said, that what we hope that was when we see him again next time, the average fixation duration will go down to this level. This is our hope for this patient. Okay, so some conclusion is, for us, it is cognitive demanding to learn multifunction hand, especially during initiation of a new grip. And what we also experience is eye tracking data can help us to determine if an amputee is experiencing excessive cognitive load, like, for example, the pupil dilator you have seen in the earlier slide, and also can also help us to know that if the person is ready to go to listen to learn more advanced functions. And gaze behavior, also we have learned that gaze behavior can be used to estimate learning progress in prosthesis users. Thank you very much. Yes.
Thank you so much, Helen. That was fantastic. Thank you so much for all these amazing presenters. At this point, I would like to invite all of our presenters to turn back on your video and your audio so we can get started with the roundtable discussion. You in the audience, please keep asking questions throughout, and we'll try to get to as many questions we have as we can in the time allotted. I know that we were running a little bit behind schedule because we had some technical issues earlier in the presentation. But we'll try to do our best for time. One thing I noticed in all these presentations is how well you all explained that eye tracking is not really only visual attention, it really means something more. So the visual attention, eye movements indicate things like hazard detection or stress or cognitive intent or cognitive load, learning, expertise, how to skill, and so much more. So it was really interesting to see all of those common threads among you today. For some of the questions that we've gotten so far, a couple of housekeeping questions. This video will be recorded, as I mentioned earlier, and will be sent out to all of the people who are attending, but will also be available on our Tobii Pro webinar hub. And it was asked as a question in the question box, so I included the link to that webinar hub. You can also Google Tobii Pro webinar hub, and it'll take you right there. It's under news and events. And you can see all of our past presentations just like this. And we look forward to your participation in those. If you have questions about our Tobii Pro systems, you can always send an email to sales, S-A-L-E-S, @tobiipro.com, and we will put you to the right person depending on where you're based in the world. We have had a lot of people from all over the world, so thank you so much for sharing where you're from. Obviously, all of our presenters are from the US, the UK, and in Sweden today. We have people in the audience from London, Ireland, other places in the US, Ohio, Germany, Sri Lanka, Taiwan, Serbia, Finland, Budapest, Hungary, Poland, Wales. So thank you so much for sharing. That's really awesome to have such a great global audience and panel. So the first question that I want to ask everybody today, I know some of you may have addressed this a little bit, and Mohammed, I'll start with you since you were just the first presenter, is what initially got you interested in eye tracking? Just tell us a little bit more about what brought you to eye tracking as a methodology in your work.
Okay, can I just pass over to Graham because he missed the presentation due to internet issues, so I'll maybe let Graham just to talk more about that himself first.
That's great.
Sure, thanks Mohammed. Yeah, sorry I was late to the party. Don't ever get Sky for your Wi-Fi, they're horrible. Yeah, I first got into eye tracking in my PhD because I did psycholinguistics. So I used the iLink eye tracker for reading, and then I got more interested in kind of applied social stuff. And it was then that I realized that the technology could be applied to a lot more useful, practical stuff rather than just kind of low-level cognitions. So I've used it a lot to research how people interact with social media. And then in this project, kind of applied in the construction industry to look at how people detect hazards in the world around them.
That's awesome. Thank you. We'll move on to Nima. How about you? Same question.
Can't hear you.
Can't hear you, sorry.
Okay, I think you hear me right now. Sorry. The reason that I use the eye tracker because it provides insight into the thought process of the operators. I use it for training of the drivers. I use it for training of the pilots, and I have different options in order to define different metrics in order to evaluate the performance behavior. Also, it has a good potential to develop training interventions for different operators in different domains. Also in the healthcare, we use it as a tool to record the video from the unit, intensive care units, and it's amazing because it doesn't interrupt the activities, so we can collect the data and then analyze the data later using different approaches, qualitative or quantitative approach, which I think this is really good for us.
Awesome, thanks, Nima. How about you, Hakeem and Helen?
Yeah. So for me, if I may start, or do you want to start, Helen?
Sorry. The question was, how do I get into eye tracking? Yeah, because our professor, he invited me to go over to his seminar, and then I sat there, and then it's also, as you can see here from my research, it's like occupational therapists always observe and kind of guessing if the person is looking. Guessing is never accurate thing. So eye tracking is the only way, or the best way at the moment for us to quantify visual feedback. So when I got to know him, that he invited actually the sales from Toby to university, and then I just emailed him without knowing him. I said, "Can I come along?" And he very generously said yes. So I was hiding somewhere among all his big people. Yeah, and then at the end we got the money to buy the glasses. So and then we start using it in the research. So he's the consultant in our project.
Yeah.
That's so great. It's really nice to see how people can work together, and eye tracking can bring people together even across different types of research, and that's exactly what we wanted to highlight today. So Hakeem, tell us a little bit about your background with eye tracking and how you got started.
Yeah, I think I could then just like give the excitement further about eye tracking that I got from Markus Nyström from Lund University, who gave a presentation at Örebro University, and I happened to end up there because it was at the end of another presentation. It was a bit of luck, but then listening to it was immediately clear how useful that could be for us in robotics. And already at the first evening, this idea was born that we could maybe directly connect to the robots, and so that the robots could react to something that we weren't even aware of. And that was just a very exciting possibility. And so we started with that. We started with what we could do in the projects that we had at the time, and nowadays this is already included in the even the larger projects, so that we have eye tracking studies there as well. So thanks, Markus, if he's somewhere there. He really initiated all that.
That's so great. Thank you so much for sharing. We are starting to get a lot of questions from the audience, so I'll just dive into those. Hi, Celeste. Thanks for your question. This is a great one, specifically, I think, for Mohammed and Graham, but I think if anybody else has comments about this afterwards, please feel free to jump in. With respect to visual search, what features measured are the best for assessing the cognitive task of recognition, so recognizing hazards or abnormal features?
Well, I mean, I think I'll leave Graham to talk about the actual measures that we use within the experiment, but we relied I'll just maybe say a few words initially. So we started mainly on relying on the gaze plots. So we used like the heat maps, which I showed in the presentation. So we relied on these as a proxy measure for the level of attention, and also we tried to prior to doing the experiment, just to say, okay, on each scene, try to map the areas of interest. And we use this as a benchmark to see, looking at different measures like saccades and obviously the eye gaze and so on. I mean, Graham can talk more about the measures as well. Graham?
Yeah, so for the hazard perception task, the ones that we concentrated most on were fixation duration and fixation count on a specific area, just because that's an indicator of kind of how interesting and how complex they think it is. So we thought that was a good measure. I think it depends on whether or not the task's kind of absolute or not, and whether they're familiar with the scene. So like in the initial scene, it was just time to identify the area that they had to identify. For the hazard perception, they were seeing a novel scene, or at least a scene set up like they maybe weren't familiar with. So in that case, maybe they didn't recognise the hazards first time, or maybe there were certain hazards clustered closer together. So then kind of visit count, and you can start looking at regressions if you go away and then come back to reassess things differently. And I think it's difficult to just pinpoint one measure, which is useful, and that's why we kind of used the interview along with it, so that as well as looking at it, the participants could talk us through it. And just by looking at their gazes, we would not have been able to understand what actually they were looking at and what they were seeing in the scene. So I think using eye gaze is important, but maybe using eye gaze along with other things is especially useful.
That's a really good point. And our in-house consulting team is called Tobii Pro Insight, and they usually use this protocol called retrospective think aloud, where they would show collect the eye tracking data for a participant and then show that replay and ask them questions and ask them to narrate what they were doing. So it's combining that qualitative and the quantitative, you get the quantitative eye tracking and the qualitative feedback, which is, I think, super interesting, probably so many cases beyond even user experience or shopper behavior, but I love that application for you all as well. That's great.
And it doesn't always work. So like if you show, for example, if you show a man a picture of a woman, then he'll look at certain body parts first. He won't explicitly say that he's looking at these body parts. It might be implicit, but I think for a lot of tasks, it is good to like have a commentary of what's going on in their heads.
Yeah, absolutely. That's great. I have a question, I think specifically for Nima, because I know you had long data collection sessions. The question was about the batteries, which I saw that you answered, but tell us a little bit more about how it was to work with a long testing session of 12 hours, knowing that you had to swap out the batteries. Tell us a little bit about the logistics of doing something like that and taking breaks with the participants.
So the nurses work during the 12 hours working shifts. So we have.
Might want to turn up a little bit or be closer to the microphone.
So we work, the nurses, as you know, in the United States, work with 12 hours working shifts. In 12 hours working shifts, so we have to be there in order to collect the data, and we ask them every 1.5 almost 12 hours using that in a specific area in order to change the battery. So his desire to have, the batteries with long working hours, but that works for us because we need to change it a few times during the shift. So that was one of the things that maybe can be improved in the future by the advancement of technology. Yeah, so I think that was your question, correct? Did I answer your question?
Yeah, that's great. I think, just making sure that you have, so I guess big picture is testing in a long session could be possible. You just have to have the right protocols, have to have things laid out, have your participants understand what they're doing and what they're agreeing to, and then have things logistically available, like extra batteries and things in case something goes wrong during testing.
Correct, and we had a team over there in order to make sure that we can do this. As you said, we need to take care. We need to have somebody constantly over there to talk with the nurses if they have any issue, if they need to change the batteries, or sometimes they need to go to rooms. We don't want to record the data, so we need to explain these things to the nurses. And in some cases, for example, for as far as I remember, I didn't participate in data collection, but my colleague at the time said that for the events that are emotionally strained for the families and the nurses, we stopped recording the data in order to respect the patient's privacy. So there are some items that we took care of them in the data collection.
Great. Awesome. Thank you so much. We have a question about the user experience for the glasses specifically. So let's start with Akeem and Helen. What is it like to use the glasses? Are they comfortable for participants to wear?
I can speak from my experience that they do not bother the patients at all. Nobody had problem with calibration or anything. So after a while, they just forget they have glasses. But sometimes, not in the videos I show you, but when the glass, you know, some people do this, and the camera is actually here, so you can actually see like they're blocking the video. But that's how it is. Of course, you don't remind them; they have to make sure. But one of the things that I noticed that sometimes I think it's nice to have a marker here, that you remember every time it's the same angle. I don't know how it affects the data, but that's I have thought about it, that not like, you know what I mean, like too high or too low. Make sure, because we do collective different assessments.
Yeah.
So,
we do have slippage compensations built into the hardware. So if they slip and go back, you don't have to recalibrate. You don't have to worry about there being offset in the data. But I guess if they slide too far off the face, if the eye cameras don't get a good picture of the eye, you may lose some data points during that brief time. I think the Glasses 3 comes with a head strap in the kit. I know the Glasses 2 definitely did. But there should be a strap that you could use to kind of put around the back of the person's head, more securely keep it on their face, so you don't have to worry about it slipping off.
So I can just second that and say that that also, even the small participants, we did a lot of experiments with young children, and they very quickly forget, you know, like age 6, 7, and they very quickly forget that they're wearing these glasses. And the only person that is stressed is the experimentator or the scientist, because you don't want them to break the glasses.
That's great. Actually, the same person asked another question, is this suitable for kids? And that's something that we as a company have said, that these will work with kids about 5 and up, but that's great feedback that you can work with 6 and 7-year-olds. I've seen some data from some of my colleagues internally that they've been able to calibrate like a 2-year-old. I'm not sure what the data would look like from, you know, the 2 to 4-year-old range, but if anybody wants to do that and be the researcher to start, please send us an email. We would love to work with you and try to support you on that to get a larger sample of kid population. See, a lot of great questions. There's a question about data here that I think is super interesting. Let me find it. So the first part of the question I can definitely answer. What support is offered to analyze data collected from the eyeglasses? Is there a module that can walk people through who are new to data collection? So yes, we have a portal called Tobii Pro Academy. It's through our customer portal at connect.tobiipro.com, and I will add that link as well. So there are modules that you can walk through on how to set up the glasses or the screen-based eye tracker, how to start your study, how to make sure that your room is properly configured, and then it'll give you some insights into what to do with fixation metrics and saccades. The second part of this question is specifically asking about pupil dilation and calculating entropy, which I believe was mentioned during Nima's presentation. So for those of you who, long story short, pupil dilation and entropy are not things that we cover at this point in our internal training, but I know they're becoming very popular to use. So if those of you who use entropy, especially Nima or pupil diameter, please talk a little bit about how you did that data analysis, so it would be great.
Okay, okay. So entropy could be measured using two different approaches. If you have areas of interest, then you can compute then you can construct the transition metrics and then compute the probability of transition from one point to another point. Then you can compute entropy based on the Shannon equation. If you don't have the areas of interest, you need to compute the probability from moving from one areas of your screen to another areas. There are some equations that you can use in order to do that, and then the rest of the computing and will be gonna be the similar. I mean, it's the probability of moving from area times by I think what the negation of this one. So if you have question, please send out an email to me, then I can provide more information to you.
Great, thank you. And Helen, I know you were presenting some of the pupil diameter. Can you tell us a little bit about how you did the analysis for that?
I just used the ProLab, exported it, extracted it, and then in a way it's quite a long process because I need to identify. I actually basically look at the video, and then if I see something higher, then like the one that I saw is like more than 4.5 millimeter, then I will see what was the person doing at that time, and he was not moving. He said he was staring at his hand, try to get into the right grip, something like this. So to me, I use that one. Yeah, but like I have always been thinking, how can you use the eye tracking glasses in a room with windows and also extract out the pupil diameter? This is my always thinking. I have never done it because we always do it in a no window room and same place, so the light is always the same.
Yeah,
so.
I think that's generally the kind of advice that we give to people who are interested in using our eye tracking systems to collect pupil diameter. So everybody is aware, our eye tracking systems do provide estimates of pupil diameter. All systems provide it for both eyes throughout the entire duration of the study. So this is a measure that you can get. We suggest that you have some sort of baseline before you show your trial or start your stimulus presentation, so you get an understanding of their tonic or baseline pupil diameter, and then measure changes, a delta change from that point on. So this is something that all people can do. There are some considerations, as Helen's mentioning. Being near a window with fluctuating outdoor light can be problematic because that's something that changes the physiological response of the pupil diameter that's not related to cognitive load. So there are lighting in the room being constant is a fantastic feedback as well. So I know that, applying something like eye tracking to measure pupil diameter in a more realistic context, like outdoors or, by window, would be really ideal. Unfortunately, I think at this point with the systems that are available, it's probably not the best, but I'm glad that you've been able to use it in the way that you have. But yes, for all people who are interested in using eye trackers for our systems to measure changes in pupil diameter, those are a couple things to think about. The data is easily exportable, and then how you can do the analysis past that. There are some simple ways. There are some more complex scripts that are available on the web or through GitHub that other people have prepared. So yeah, feel free to email us if you have any other questions about that as well, or for anyone here. There's a question for you, Akeem. Can the robot receive the gaze data of the viewer and pick up the interested objects and deliver them to the viewer? Like a delivery system.
Yeah, this is generally possible. We are currently working towards like what we would call semantic eye tracking, so that actually the gazes do not come only as coordinates with respect to the scene view, but with information what object it is. And you have maybe seen that in the video that I showed from the driver's view. There, it makes a big difference whether the person looks at the cyclist or at the sign, then what a sign it is. So our idea would be that the robot would get information in this form. Person looks at the object on the shelf. Person looks at your projection. Person looks at the robot, and so on. So it's not all implemented what I'm talking about. That's some of it is our vision. But the general components are there. We actually create with the robot a three-dimensional map. We extract semantic information, and then we just need to connect it to the coordinate system of the wearable eye tracker.
Great, Thank you so much. I know we're kind of running out on time, so I'll ask one last question of everyone here. It's a great question that came in the chat, and I'll just have everybody answer it for their own industries. What's the future for eye tracking in your field? And let's start with Mohammed and Graham. What do you think the future is going to be like for your fields of cyber psychology and construction science?
You can start, Graham. Go ahead.
I think there's two things. First would be using eye tracking in conjunction with other technologies to maybe look at, for example, imaging at the same time as eye tracking. The other one would be to maybe get a more fine-grained way of measuring stuff more fine-grained using the glasses, because we're moving away from the desktop machines where people typically view things to mobile devices. So there's different layouts, different affordances with the device. So there's a way to accurately measure what's going on when participants look at a mobile or a tablet rather than a desktop.
Yeah, I would echo that in construction, definitely combining other technologies like, for example, virtual reality or VR. Now HTC Vive, they have an integrated eye tracker. So I think that would be really amazing to do some for health and safety training as well. And I think that's why I saw the link. So I think to see like technology integration and how this could be applied in a context maximize impact, especially for health and safety. I think construction is still playing catch up in terms of embracing new technology. So I think there's a lot of potential for using eye tracking for not only for health and safety training, but also for quality assurance on site in terms of process improvement and in terms of quality control and so on. So there's a lot of potential there.
Great, awesome. How about you, Nima? What do you think is the future for eye tracking in healthcare? And
I believe that AI-based eye tracking tools gonna be used in the healthcare in order to help managers to better support nurses. For example, if in case that a nurse feel overloaded or is under stress and the nurse cannot accomplish or deliver quality work, then the manager can get some feedback from the eye tracker and send out some people to help the nurse. Also, I think in the future we're gonna see more video analysis, real-time video analysis in the future to help nurses in order to accomplish different tasks, maybe help them with the some of the drug calculation for the patients or different type of tasks to make it easier for them and less demanding as well for the nurses during the shift.
Thank you. I know, Akeem, you had mentioned a little bit about sort of the future in robotics, but tell us some more, like what do you think your field will be like in 10 to 20 years, especially as it relates to eye tracking?
What I can say is also for our efforts in education research, especially mathematics education research, there we have a group, an international group about eye tracking in the field. So there, this is one development that we see, that you now have studies that look into a classroom where several students have the glasses, the teacher has the glasses, and then this leads to very interesting studies. The second direction that I want to mention is connected, because, you know, as I said, this leads to very interesting studies, but also to very heavy evaluation if you need to do it manually, because you have 4 different video streams, 4 different eye tracking or 5 different eye tracking devices, and then in additional data, transcripts and so on. So the second direction that I want to mention is artificial intelligence, in order to evaluate the experiments by, for example, recognizing what the person looks at, what the participants looked at, or by just a pre-evaluation, by pre-segmenting the videos and cutting out what could be interesting for the researchers.
Awesome, thank you. And Helen, same question for you to wrap up our panel today. Where do you see the future of eye tracking in your field in cognitive rehab?
I think more and more people were using eye tracking in the upper limb prosthetics, because we have one reason is because there are new hands coming out. new hands, more advanced functions, which means that it takes more cognitive burden on the person to learn the hand, how to get a balance between you get the advanced functions, you learn how to use them, but at the same time, easy to use. So not taking too much brain. I think this is I think more manufacturer, instead of only clinicians, manufacturers should use eye tracking to see when the first prototype come out, to just see how difficult or how easy it is to learn it, to operate it.
That's, yeah, it's such a good idea. Awesome. Well, we'll wrap it up here. Thank you so much to all of our wonderful presenters for being here today. Thank you to our audience for such great questions and for your engagement. This will be available again via email and via our webinar hub. We'll take any questions you want to send us at sales@tobipro.com, and we look forward to seeing you at our next event. Have a great rest of your day.
Thank you. Thanks.
Thank you very much.
Thanks for the invitation. Bye-bye.
Bye-bye.